Okay, in this profit question here, we have a telephone exchange company that has a profit of $12 a year for each subscriber if there's not more than 1,000 subscribers. So currently the revenue is the number of items, which are the 1,000 subscribers, times the price per item, which is a total revenue of 12,000. But what they find is if the number of subscribers exceeds 1,000, then the profit on each phone is decreased by as many cents as there are subscribers over 1,000. So what that means is as I increase my subscribers, that's the number of items, by multiples of 1x, so for every one person, I decrease my subscriber fee or my profit by 1 cent, as many cents as there are subscribers. For example, if I have 5 subscribers, new subscribers over 1,000, I decrease the net profit by 5 cents. If I increase by 100 subscribers, I'm going to decrease by 100 multiples of 1 cent, which would be $1. Okay, so my max revenue equation, my new equation, is going to be my 1,000 subscribers, that's the number, plus multiples of x, and my profit is going to be $12 decreased by multiples of 1 cent x. So let's go ahead and apply the distributive property to get rid of my brackets. So I'm going to do 1,000 times 12. I'll do 1,000 times 1 cent x, which is going to be negative 10x. 1x times 12 is 12x. And then 1x times negative 0.01x is negative 0.01x squared. So let's write this in descending powers of x, negative 0.01x squared, combine my like terms, plus 2x plus 12,000. So I want to complete my square now. And to do that, I'm going to factor out my leading coefficient just from my x terms. So my max revenue is going to be negative 0.01. Take that out. So negative 0.01 x squared divided by negative 0.01 is x squared. 2x divided by negative 0.01 is negative 200x. Let's leave some room, and we have our 12,000 on the outside. So let's go ahead and complete our square now. So I have x squared that goes here. I take negative 200x and I divide it into 2 equal pieces. Factor out my GCF, take out my leading coefficient, and let's double check that. So I always like to check just to make sure I'm right here. So x times x is x squared. Negative 100 times x is negative 100x. X times negative 100 is negative 100x. Negative 100 times negative 100 is positive 10,000. So inside the brackets, I'm going to add 10,000 and subtract 10,000. I do that again because that's 0, and you can add 0 to any equation without changing its value. So back over here, max revenue, negative 0.01. Let's factor our perfect square trinomial, which factors as x minus 100 times x minus 100, or x minus 100 squared. Now we have to deal with that negative 10,000, so let's take negative 0.01 times negative 10,000 out. So I do negative 0.01 times negative 10,000, and what comes out is $100 plus the 12,000 that is there. So just to finish this off, negative 0.01 x minus 100 squared, grouping my like terms, plus 12,100. Oops, one too many zeros. I was getting excited about my profit. Okay, so let's interpret our vertex. So our vertex is opposite on the inside 100, straight up on the outside 12,100. So this is what my max or min is. This is when my max or min occurs. So in the context of the question here, this is negative, so I have a parabola that opens down, so it is a maximum, and that is the maximum profit or revenue. So maximum profit is 12,100. Now when does it occur? It occurs when 100 multiples have gone by. So if we go back up here, we were increasing our membership by multiples of 1x, and X is 100. So we're increasing it to be 1,100 subscribers. And what's the price or the profit? The profit is going down by multiples of 1 cent X, and we found that there were 100 multiples. So subtract 1 cent times 100. So it's going to be 12 minus 1 is $11. So let's make this a little bit bigger so you can see it. So it's going to be, oops, let me try that again. There we go. So it's going to be 1,100 subscribers will give the maximum profit. That maximum profit is $12,100, and it's going to be $11 per person. So you can even check that by doing 1,100 times 11, and you get $12,100.